Solve using any appropriate method. Our system of linear equations is 4x minus 6y equals 3 and 6x minus 4y equals negative 3. Since they're both in the same form, I'll go ahead and use the elimination method, sometimes called the addition method. It doesn't matter whether I want my x's to drop off or my y's to drop off by addition, so I'll go ahead and just choose the y's. And the least common multiple of 6 and 4 would be 12. So this equation then needs to be multiplied by 2 so that I can end up with a 12 here. So that new equation then is 8x minus 12y equals 6. Now since I also want a 12 here, but I would prefer the signs to be the opposite so I can add, then I'll multiply this one by negative 3. That gives me a new equation of negative 18x plus 12y equals, and this will give me a positive 9. These two equations are equivalent to these two equations, but now they're more useful. So as I add them, 8 and negative 18 will give me negative 10x. And you can see here that my y's will drop out of this new equation. And then 6 plus 9 will give me 15. So now I just need to solve for x. So I'll divide both sides by negative 10. So I'll go ahead and leave this as a fraction. So x is going to be negative 3/2. Now I need to substitute this value back into either one of these equations. It doesn't matter which one. So I'll go ahead and just use the first one. So we have 4 times whatever x is, which is negative 3/2, and then minus 6y equals 3. So this gives me an equation with only y in it. So now I can find what y is. So starting here, I'll cancel these. 2 divides 4 twice. So this gives me negative 6 minus 6y equals 3. Adding 6 to both sides gives me negative 6y equals 9. I'll go ahead and write that up here, because my last step then is to divide both sides by negative 6. And since I wrote the other as a fraction, I'll go ahead and write this one as a fraction. This gives me, dividing the top and the bottom by 3, I'll get negative 3/2. So the final ordered pair then is negative 3/2, negative 3/2. So this is the pair of numbers that will make both of these equations true.